Hi everyone, this is Pradeep. Welcome to my YouTube channel, which is Day One Pradeep. Today we're gonna solve Leetcode question, which is number of 1 bits, which is previously asked in Amazon. Let me explain the problem description, which is nothing but we need to find out. They're gonna give input an, which is nothing but integer. We need to find out number of ones which when it is represented in the binary form. Let me explain with the example. Suppose n, which can be represented as 0 1 0, so the answer will be 1, as it has uh, one integer here in the binary representative form. For let me take another example. For n equal to 3, here 3 can be represented as 1 1, so the answer is 2. The number of ones present in the binary representation of 3 is nothing but 2 ones. So let's dive into the solution. Before going to the solution, we need to understand what are the constraints are. It helps us to maintain the conditions, what are the edge cases, and what will be the output. It's gonna give you all the ideas from this constraint, a little bit of idea. Here you can see that integer n will be in the range of 1 and 2 power 31, which is nothing but int. So uh, of course int is nothing but 32 bits, so our answer lies between in the range of 32 to 1, that's for sure. And n value will be always greater than 0. Okay, we don't need to worry about the negative integers here in this problem, because they are given the constant this, so there is no need of writing the case if when n equal to negative or something. So let's dive into the solution. The first approach is nothing but right shift, binary shift operation, which is pretty efficient. And let me explain why we are using the right shift operation. First, suppose as it is an integer, let's n value be level, and what's the what you could say, what's how level is represented in the binary form, which is 1 0 1 1, right? So I'm gonna have zeros until 32 bits. Here my approach is that I'm gonna shift all these integers until it becomes 0, and every time I'm gonna do that operation. Before that, I'm gonna do end operation with 1 to figure it out. The number of 1 is the 1 is present at this position particularly. Let me explain with with example right now which I am taking. First, suppose as I mentioned, I'm gonna do end operation every time. So before doing the right shift, here the answer will be, which is 0. Here why you should know why I'm doing here end operation, because I need to find out the 1 is present at this position. I'm gonna know that my priority is that to know that is the at this position 1 is present or not. If 1 is present, I'm gonna increase the count, otherwise count will be nothing. So here I found out that okay, 1 is present, so I'm going to do right shift again, which is nothing but 0 0 1 0 1, and I'm going to do again end operation with 1, which gonna find out okay, 1 is again present. I'm going to increase the count again, which is nothing but 2 here, and do the right operation, which is 0 0 sorry, which is 0 1 0 0. Let me erase this. So okay, let it be. So I'm going to do end operation with 1 again. So here I found out that there is no 1 here, so I'm not gonna increase the count and do the right shift again, which is 0 0 0 1. I'm gonna do again end operation with 1, which is yes, I have 1 here, so I'm gonna increase the count here again and do the right shift, which is nothing but 0, exit the loop. So this is the best approach. This is the approach we are going to do. Let me write the pseudocode for this. Which is nothing but have a while operation until n, which is until n is not 0. What do you do? Yeah, have count plus count plus end ampersand 1, and next I'm gonna do right shift for the 1 bit. Okay, I think this is the whole logic. You may think that it's gonna add any additional bits. No, in the previous example, when in this case, when this 0 has came at this 1 position, when I do end operation with 1, it result 0 end operation with 1, which is nothing but 0, which gonna not add any additional values here. Got it? So this is the one approach, and here it's gonna take order of 32 time and order of 1 space. You may think, why order of 32? Because it has 32 which is nothing but order of 1 ultimately. Order of 32 is nothing but, because it is integer, it has 32 bits, so it's gonna iterate every, in worst case scenario, if integer as, let me erase it. In the worst case scenario, if it has 0 and in between it has 32 sorry 1 30 zeros in between, and at 31st position it has 1, it's gonna take order of 32 time. So is there any better approach? I know this is a better approach, it is order of 32, but in general solution you think that if it is an array, it's gonna take order of n time. As a programmer, I also know ultimate achievement is that to achieve algorithm in order of n time, that's a best optimal solution. But you can do it in more optimal way. You can achieve this solution under the time of order of log n. Yes, there's an algorithm which is Kengra's algorithm, which is nothing but n equal to n. This is the algorithm we're gonna use, and every time I'm gonna use this algorithm, regardless of result, I'm gonna increment my count. Let me explain why I'm using particularly this algorithm. For suppose, like I said in the previous example for level, let us take the previous example, which is nothing but 1011. So let us do this thing. So here n equal to, which is nothing but 1011, and n minus 1, which is nothing but 1010. Here again n equal to this is n, this is n minus 1, so 0 1 0 1. Again, now the n value is this, and n minus 1 is which is nothing but 1001, it is 0 0 0 1. Again, here you need to see this is the value of 11, this is the value of 10, and this is the value of sorry, this is the value, sorry, wait a minute, yeah, okay, this is the value of 9. Oh, sorry, this is the value of 10, sorry, yeah, sorry, and this is the value of 9, and this is the value of 8, and if I decrease 1, which is nothing but 0 1 1 1, which is 7, it is 0. So every time I do the operation, I'm gonna increase. Here I have did the operation which I'm gonna increase here at this point, increase the count, which is 1, and here I am gonna again increase, which is 2. Here I'm gonna increase again, which is 3. As n equal to 0, it's gonna exit from the loop. Let me write the pseudocode. Yeah. Sorry. Yeah. While of n. Yeah. So this is the as you see in the example, if you take any example, try it by doing on the white sheet or something, try it on your own. You can find out that every time you do the algorithm, it is nothing but eliminating the steps, and we have achieved that solution. Previously it had took 4 times we need to shift all the things, but here we achieved in 3 steps, which is nothing but equal to log of n time complexity. You can achieve this solution you are under the time complexity of log of n. And yeah, while doing this problem, I figured out why how the programmer has been come to this approach. It is nothing but, for suppose if I take the number level again, sorry, I'm using the solution again and again because I want to prove the solution. Here you can see, right, here I'm reducing one value from that, which is nothing but removing one bit. I'm changing the positions of other bit. Whenever you negative one value from the integer, it's gonna shift all the positions of that number, and in such a way that it gonna eliminate only one bit from that whole integer. Here you can see, right, 1 0 1 1. If I eliminate here, reduce it with -1, it's gonna result me that 1 0 1. Again, either it gonna remove one bit or it gonna change the position of those bits. 0 1 0. Here again, when I do -1 for this one, it gonna give me 1 0 0 1. See, these are the only two conditions when you do -1. Either it gonna remove one bit from the number, either it gonna change the position of the one bit so that it doesn't match the previous solution. Of course, it doesn't match if you negative with the, I think you got the intention what I'm to prove it to you. This is the main intuition why he has used -1 particularly for this and do the end operation. I know, which is pretty brainstorming and all of those things. You cannot figure it out during the interview. If you figure it out during the interview, I'm gonna say you're gonna get way more big position from my standard, I could say. Yeah. Yeah, that's it. Thank you for watching the whole tutorial, and leave a comment section what are your opinions, how where I can improve and all of those things. I consider feedback very valuable, and follow this channel for more interesting videos like this, and I'll be adding videos regarding the career perspective, software and everything. And this is the Leetcode because I'm been practicing for my company, so I'm adding these videos. but I will add these videos until I get the job. Thank you, and follow this channel for more interesting videos like this. Please subscribe and share. Thank you.